We often look back at antiquity, and honestly, we really only see the stone, the marble temples, the sweeping monuments, but the actual, true engines that drove these massive empires, they were forged from materials that were far, far more fragile. Welcome to Vantage.
So I want you to imagine a city of 1 million people. 1 million people. Now, really picture all of those people packed tightly together into these towering, timber-framed high-rises, reaching up to 6 stories into the sky. There is literally no street lighting, and this entire massive populace is absolutely 100% dependent on open flames for every single basic human need. We're talking cooking, heating, lighting, the whole entire spectrum of daily life.
These structures, they were called the insulae. They were basically these dense, highly kinetic mazes of timber apartment buildings that just completely dominated the Roman urban landscape. And if you're a citizen living inside one of these wooden labyrinths, well, fire wasn't just some rare, unfortunate hazard. It was a looming, ever-present apocalypse.
You see, in a high-density urban experiment like Rome or Pompeii, your margins for error were practically zero, just non-existent. One single overturned oil lamp, or maybe just a stray ember from a hearth, and boom, it could instantly ignite a massive, district-wide catastrophe. And that kind of absolute devastation, it directly threatened the very stability of the Pax Romana itself.
But here's the fascinating thing. The Romans did not just meet this fiery chaos with simple buckets of water. They were brilliant engineers. They fully understood that desperately throwing small splashes of water at a towering inferno was basically a futile effort.
Instead, hidden deep within the archaeological record, there is this true masterpiece of mechanical engineering. It's an invention that fundamentally redefined urban safety for the ancient world. I'm talking about the wooden, 2-cylinder force pump.
Now, history obsessively documents the stone achievements of Roman civil engineering, right? We all know about the grand temples, those sweeping paved roads, the monumental aqueducts, but their achievements in mechanical engineering, those remain a fascinating, hidden gem.
And the reason they're so hidden is, well, it's tragic, but entirely inevitable. These machines were painstakingly crafted from organic materials: wood, leather, and rope. And because of that, they usually just fell victim to the relentless forces of recycling and completely rotted away through organic decay.
But today, we're going to interrogate a very rare survivor. It's known as the Perigus Superstar. This is a profoundly important 2,000-year-old machine that proves, without a shadow of a doubt, that Roman engineers were not just builders of static stone. They were absolute masters of fluid dynamics and, amazingly, mass production.
Throughout this documentary, we're going to trace the fascinating evolution of this vital technology. We'll follow its incredible journey from a theoretical Greek bronze prototype all the way to a rugged Roman wooden reality. We'll explore the high-tech interrogation of a completely submerged ancient pump, and ultimately, we're going to uncover the massive human engine of slavery that powered the whole operation.
Now, as with almost every truly great Roman invention, it inevitably began with a Greek alpha version.
The fundamental underlying concept of the force pump is originally attributed to Scythibius of Alexandria. He was this absolutely extraordinary, visionary mind who flourished way back around 270 BC.
And his original design, he was an absolute marvel of bronze. It involved these highly intricate metal parts that had to be precisely cast, and then painstakingly soldered together just to create a reliable, watertight seal.
So effectively what he built was the high-end, luxury prototype of the ancient world. Was it brilliant in its conception? Oh, absolutely. But it was also prohibitively expensive and nearly impossible to actually maintain in the unforgiving, dirty grit of a real Roman street.
It really was a boutique luxury technology. A fascinating intellectual curiosity, sure, but something that could literally never be deployed at the sheer, overwhelming scale that a massive, sprawling empire required.
This is exactly where the true Roman genius lay. It wasn't always in having the very first idea, but in the ruthless, brilliant process of re-engineering.
Roman engineers looked at that expensive, delicately soldered bronze nightmare of a machine, and they systematically transformed it. They basically stripped away all the luxury, all the delicate metalwork, and they rebuilt it into a rugged, incredibly reliable wooden powerhouse. They made this incredible shift from pieced-together metal to an organic monocoque design. Now that just means it had a unified structural skin derived entirely from a single solid block of material. And that shift, it was nothing short of revolutionary. It made these pumps drastically easier and drastically cheaper to manufacture and keep running.
It's a process that is entirely familiar to anyone looking at modern production lines today, right? You take an initial overly complex design and you improve it by fundamentally altering the materials and the methods of manufacture until you reach true, scalable mass-market efficiency. Because the Romans realized a really profound truth about emergency response. For a machine to actually be effective at fighting a massive citywide fire, it didn't need to be pretty. It needed to be entirely replaceable and immensely rugged.
And the actual construction methodology they developed to achieve this, it was just truly, deeply ingenious.
Instead of carefully assembling 50 different fragile metal parts, a Roman engineer would take a single massive block of seasoned oak. Then, using these heavy hand augers, they would literally bore 2 huge cylinders directly down into the very heart of the solid wood. What this elegant reduction did was create a unified, perfectly solid vessel. It was inherently capable of withstanding immense hydraulic stress. And the best part? It did it without any need for fragile gaskets or metal welds that could easily fail under pressure.
Now, to connect those twin vertical cylinders to the central outlet pipe, they obviously had to drill horizontal passages intersecting them. And then they used what we can really only call a genius ancient hack. They simply took dense wooden plugs and they hammered them incredibly deeply into the extremities of those horizontal holes to seal the internal spaces right back up.
Because the moment those wooden plugs swelled up with water, the seal became absolutely perfect. It created a perfectly pressurized internal chamber, locked forever within the raw organic material of a tree trunk. For nearly 2 millennia, these Roman pumps were ghosts in the text, described by ancient authors, but never seen in their complete form.
Well, that all changed in 1972, right near the Vigiles Temple in France. Down at the bottom of a 10-meter well, archaeologists uncovered what can literally only be described as the superstar of Roman pumps. And, what's really fascinating about this discovery is that it wasn't just some pile of fragmented splinters. No, it was a remarkably intact piece of engineering history, just waiting to be understood. It had actually been preserved for nearly 2,000 years because it was buried in a perfect time capsule cocktail of water, sand, and clay. So the absolutely crucial point here is that the specific geological conditions of that well acted almost like a giant vacuum seal, totally locking the artifact away from the destructive elements of time.
This unique, oxygen-free environment prevented the rot that had already claimed thousands of other Roman machines. It left this heavy oak block in a state that looked miraculously close to functional. It's kind of crazy because usually organic materials like wood simply vanish over millennia, but this complete lack of oxygen arrested the decay process entirely.
Section 1. Non-invasive interrogation.
Modern researchers did not merely eyeball this find. Because the artifact was so incredibly fragile, they couldn't just tear it apart, right? Instead, the Ausonius Institute utilized magnetic resonance imaging, or MRI technology, to digitally integrate the wood without ever laying a finger on it.
These scans allowed them to precisely measure internal nails, exact dimensions, and invisible measurements that were otherwise completely hidden from the naked eye. This brilliantly illustrates how modern medical technology can be repurposed to peer deep inside ancient artifacts, revealing structural secrets that would normally remain a total mystery to us.
By analyzing that MRI data, they were able to look right through the grain to identify the exact path of the bored holes and the thickness of the internal walls, building a digital bridge directly back to the 1st century. It's honestly like they were looking right over the shoulder of the original Roman carpenter who carved the block.
Section 2. Cinematic 3D reconstruction.
Taking these detailed internal scans, the Ausonius Institute built a full 3D CAD model to cinematically reconstruct the machine's internal life. To evaluate how well the pump actually performed, they applied conservative equations, specifically mass and energy conservation. This really builds our understanding of its physical limits.
They relied on what's known as the quasi-static hypothesis. In simple terms, this simplifies the effects of inertia, allowing researchers to accurately calculate the sheer physical manpower that would have been required to drive those pistons.
By isolating the energy variables, they could figure out exactly how hard a person would have to work to lift water using this specific mechanism.
The results were absolutely astounding. They revealed a machine that was not just a historical curiosity, but a highly efficient tool specifically engineered for lifting water from great depths. It proves, without a doubt, that Roman hydroengineering was incredibly sophisticated, maximizing output while completely minimizing the human energy required.
Section 3. Experimental Archaeology. So to physically validate their mathematics, a team at the Wood Technical Institute in Periga spent 3 long years on a pedagogical project to rebuild the machine at a 1-to-1 scale. This wasn't destined to just be a static museum display either. It was built to be a fully functioning replica. While traditional oak was used for the historical structure, the team cleverly used clear plexiglass for the cylinders. This allowed them to physically observe the water's behavior and watch the movement of the internal flap valves in real time. It's just a perfect blend of ancient design and modern analytical materials, letting us see exactly how the mechanics played out under pressure.
This is experimental archaeology at its most rigorous, moving from virtual scans to a physical machine that you can touch and operate.
In Rome, technology was never divorced from the reality of human labor. Behind the gleaming marble and the mythological grandeur of the empire, there lay a brutal physical truth, a truth that quite literally powered the greatest civilization of the ancient world. Back in 22 BC, Emperor Augustus looked upon this sprawling, chaotic capital and realized that the city desperately needed a professional defense. You see, the threat of fire and ruin was a daily reality that required both a mechanical and a human solution. Rome was growing exponentially. Its wooden insula, those ancient apartment blocks, were stacked high and tight, creating a massive tinderbox just waiting for a spark. And to combat this, he initially organized a fire department using a staggering force of 600 state slaves. This wasn't some noble civic duty, it was forced labor on an industrial scale. These men were the property of the state, weaponized against the flames to protect the assets of the elite. He essentially told them that the safety of the world's greatest city rested entirely on their backs. Technology, like the advanced double-action force pump we've been examining, was merely the tool. The slave was the human fuel that actually made the high-tech life of the elites possible. Without the immense physical exertion of these enslaved individuals, the engineering marvels of the era would literally just sit there, utterly useless. The contrast was just staggering. While the wealthy patricians reclined at decadent banquets that could last for 22 courses, these public slaves were the ones hauling heavy brass and oak pumps through the dark, perilous streets to every single emergency. They had to navigate the narrow, winding alleys of the Suburra, rushing straight toward the suffocating smoke while the masters of the world dined in unbothered luxury right above them. Of course, this system eventually required an upgrade. The sheer scale of the city demanded more. By 6 AD, Augustus professionalized the force, transforming them into the Vigiles, or the watchmen. This was a completely critical turning point in urban administration, a stark recognition that the safety of the empire's heart required a dedicated, militarized approach. 10-second dramatic pause. This evolved into a massive corps of 7,000 men. Composed mostly of freedmen and slaves, they relentlessly patrolled the 14 regions of Rome in tightly organized groups of 10, known as ducerii, every single night without fail. They were the ancient world's first responders, armed with axes, buckets, and the formidable force pump. They hauled these incredibly heavy oak force pumps to every alarm, providing the raw, physical muscle that kept the heart of the empire beating. It was a massive, highly specialized human workforce. It was the hidden economy that allowed Rome to maintain its global stranglehold. They operated in the shadows, literally and figuratively, ensuring the machine of Rome never ground to a halt. All while the elite looked upward, focusing on the cosmic order of the state. There is this visceral, almost shocking contrast between the pristine cosmic order of monuments like the Pantheon and the gritty, unrecorded reality of the streets. The architecture of power was specifically designed to project a divine mandate, intentionally obscuring the sweat and the suffering that sustained it. Take the Pantheon's massive dome, for instance. It reflected the ancient templum of the gods, engineered with such awe-inspiring precision that aligned perfectly with the sun on the traditional birthday of Rome, April 21st, to quite literally crown the emperor in divine light. It was an absolute masterclass in propaganda through engineering, a space that demanded reverence and reinforced the absolute authority of the ruling class. Yet if we look away from the heavens and down to the bottom of the dirty tavern walls where the Vigiles actually lived, we find what historians call savage communication, raw, unfiltered graffiti that entirely escaped the rigid rules of the elite. These hastily scratched words and images give a voice to the voiceless, revealing the coarse, vibrant daily life of the men who actually ran the city. 10-second dramatic pause. Here we find the copper S, the currency of the gutter, where for the exact same price as a basic loaf of bread, a man could buy a fleeting sexual encounter in a dim tavern. This was the brutal, unvarnished reality of the lower classes, far removed from the philosophical treatises and marble statues of the patrician class. The advanced force pump didn't just put out fires, it protected this divided world. It was a physical manifestation of a society built on high-pressure mechanical precision and systemic, slave-driven control. The technology preserved the hierarchy. It ensured that the grand villas and state buildings remained perfectly intact even as the lower classes burned through their short, incredibly difficult lives. This Roman mechanical engineering was fueled by an industry of terrifyingly massive scale. Massive brick factories, staffed by 50 exhausted slaves at a time, continuously turned out the raw materials required for the city's sprawling infrastructure. The repetitive, back-breaking labor in these factories was the literal foundation upon which the empire's grandest visions were built. When we look closely at the mechanics of the force pump, we see that the Romans were facing the exact same questions we grapple with today. How do we make our tools more reliable? How do we make them more cost-effective? And fundamentally, how do we protect the dense populations of our cities from the ever-present threat of fire? The engineering challenges of urban density are completely timeless. This teaches us a really profound lesson. The Roman Empire did not simply collapse into dust. It dissolved and it evolved. Its sophisticated engineering blueprints survived the centuries, becoming the very foundation for the modern world we inhabit today. The principles harnessed in those ancient oak cylinders still beat within the industrial machinery of the 21st century. Throughout this deep dive, we have traced an incredible technological flow. We've seen how the Romans industrialized early Greek prototypes, how modern MRI technology allows us to peer 2,000 years into the past to examine their work, and how the massive human engine of slavery made this high-tech reality possible. It is a complex legacy where brilliance and brutality are forever intertwined. 10-second dramatic pause. The Paraguch pump stands today as a superstar of antiquity. It is a stunning testament to ancient intelligence that reminds us that the quest for efficiency, survival, and safety is an eternal human pursuit. But it is also a haunting artifact that forces us to reckon with the true cost of civilization. Here is the list of sources for this investigation. Reflection on a Method for Archaeology of Technical Machine, Roman Wooden Force Pump of Paragu, Roman Slavery, A Study of Roman Society and Its Dependence on Slaves by Andrew Mason Burks, Daily Life in Ancient Rome by Jerome Carpapino, Interrogating the Collapse of the Roman Empire by John Pesner, The Role of the Sun in the Pantheon's Design and Meaning, Graffiti in the Literary Landscape in Rome and Pompeii by Christina Milner, and Rome and Pompeii, Society Through Graffiti by Marie Carr. When we peel back the polished marble and myth of antiquity, we don't just find forgotten mechanics. We uncover the raw human machinery that sustained a global empire. These brutal, hidden, ancient systems birthed the very infrastructure of our modern world. It forces us to confront the fact that progress is rarely built in a vacuum. It is forged by the hands of those history often attempts to erase. That is what it means to look past surface. That is the philosophy of vantage, seeing everything differently. So we must ask ourselves, what hidden human engines are powering our world today? If you want to see more deep dives into the hidden high-tech and lost voices of the ancient world, make sure to subscribe to Vantage. Join us next time as we unlock more secrets of the Roman Empire. Stay curious and stay tuned.